going to discuss the experiment of rolling a fair die. Recall that in probability, an experiment is simply anything that allows one to make an observation. When we talk about a fair die, we're talking about the basic six-sided cubic die where the faces are marked with either 1 or 2 or 3 or 4 or 5 or 6 spots. The set of all possible outcomes is called the sample space. And here we see that the sample space is the set 1, 2, 3, 4, 5, and 6. So the first thing we're going to do is construct a probability distribution table. A probability distribution table consists of two columns, an X column and a P of X column. The X column represents the values of the random variable. So X equals the random variable. It is considered a random variable because it does not take on an actual value until the experiment is conducted. The possible values of the random variable are the sample space. So in the column for the random variable, we will put all values of the sample space 1, 2, 3, 4, 5, and 6. Now the P of X column represents the associated probabilities. So P stands for probability. P of X means the probability of X. So if X equals 1, the probability P of X will be the probability of rolling a 1. Since this is a fair die, that means that all sides are equally likely to appear. So fair means all outcomes of this die are equally likely. Since there are 6 possible outcomes and only one way to roll a 1, the probability of obtaining a 1 is 1 out of 6. The same is true for all the other outcomes. So this is a probability distribution in which all the outcomes are equal. Recall that the probability of anything in the sample space occurring has to equal 1, so the sum of all these probabilities is 1. So this is the probability distribution for rolling a fair die. All the probabilities are equal, so this is referred to as a uniform distribution. What we're going to do next is construct a probability histogram that is simply a graphical representation of this probability table. So to do this in Excel, we are simply going to highlight the entire P of X column, including the heading or label P of X. Then on the menus on top, you're going to go to Insert, and then over here in Charts, you're going to choose the column chart. You can choose either a 2D or a 3D column chart. I prefer the 3D chart, so here it is. I'm going to make this a little bit smaller so we can see it in the screen. Right, and we see that all the bars are equal height. Here, the vertical axis represents the probabilities, and the horizontal axis represents the values of the random variable. Now in a histogram, we do not want these gaps between the bars. So I'm going to show you the fastest way to take care of this using Excel 365. First though, I want to be able to distinguish my bars once the gaps are closed so that I can see it indeed is a column chart, not just a flat wall. So what I'm going to first do is over here in Chart Tools, I'm going to click Design. And then for a 3D, I like Design 12 here, Style 12. So I'm going to click on Style 12. This needs to be done actually before going to the Quick Layout. So choose your chart style. I prefer 12. And then I'm going to go to Quick Layout, and you'll see that here Layout 8 automatically closes the gaps. So I'll select that, as well as give us space for the axis titles. The horizontal axis title is X. Notice when I type in X, it prints up here, and it's not until I hit Enter that it shows down here. So I'll click here. My vertical axis title is P of X. All right, so there it is. And this is a uniform probability distribution, so I'm going to title it as such, or I should say probability histogram. The uniform probability histogram, and there it is. So this is uniform. All the bars are the same height, and so this is what we call symmetric because it is the same on the right and on the left. This is a symmetric probability distribution. Now there's a couple additional things we're going to do to analyze this. One of these things is called the mean. We want to find the mean of this uniform distribution. And the mean is a weighted average. Okay, the mean is the weighted average. And the way we're going to find the mean is really simple. We're going to use a built-in formula called sum product. Now, since this is uniform, if the mean is the weighted average, then you can think of the average as the balance point of this histogram. Now, since this is symmetric, the balance point would be exactly in the middle. So the mean is a way of defining the middle, and it precisely is the middle when you have a nice symmetric distribution. So on this distribution, we can see that the mean is going to be 3.5, or is 3.5. Since it's actually a weighted average, I'm going to show you how we would compute that so that we can do it for any general probability distribution, not just a symmetric one. And that is to use the formula sum product. The formula sum product can be found in the Math Trig folder, and they're in alphabetical order, so you scroll down until you see sum product. So the sum product of the values of the random variable, so in array 1, I'm going to highlight all the x values, and array 2 are the associated probabilities because those are the weights. And you can see here the average is 3.5. I click OK, and there it is. Now another way to bring up a formula is you can simply type equals and start typing in the formula, so sum product, and then you can either finish typing it or double click where it shows up, and then it will show you down here what the arguments or inputs are. So array 1 would be the x column, type in the x, array 2 would be the p of x column, and close the parenthesis and hit enter. All right? So you could do it either way. So the reason we use sum product is because it's a shorthand version of doing x times p of x for each value of x, and then summing up all those products. So it's a sum of the products of the x times p of x. You could actually denote that here as we are writing the sum product of the x and the p of x columns. All right, so that is what we call a measure of central tendency, or the middle. That's one way of defining the middle. It's also called the expected value, So the mean is a way of defining the middle. It's also called the expected value because it would be the expected average if this experiment were conducted many, many times. So that gives you a measure of the middle. So there is another measure we want, and that is to describe how much the data is spread out about the mean. So we're going to compute something called the variance. The variance is a measure of variation, how much the data is spread out. And that will be found by computing the weighted average squared distance from the mean. Weighted average squared distance from the mean. So what that means is we first have to find the squared distance from the mean. So we are going to compute the difference, x minus the mean, but then we're going to square it to make it positive because we want only positive values. So this is the squared distance from the mean, okay? Or you could think of it as a squared difference. But distance gives you a physical understanding of here's the mean, here's 4. The distance between the mean and 4 is 1/2 when it's on the right, but here the distance between the 3 and the mean, since 3 is on the left, is negative 1/2. But we don't want positives and negatives because then when you add them, they cancel each other out. So to make them all positive, we simply square them. So we're going to do that here, and we're going to use Excel to write a formula. So I'm going to have equals, open parenthesis. And now instead of typing a 1, we're going to click on the cell that contains the 1. So notice that's A5, minus, and instead of typing out the mean, I'm going to click on the cell that contains the mean. Now, when you click on cells and then you copy the formula, Excel will actually automatically change if you move to different rows or columns. So for example, this A5 in the formula, if I copy this formula down, it will automatically change from A5 to A6, A7, A8, A9, and so on, which is exactly what we want because we want the X values to change as we move down. The B13, however, we want to stay the same because we always want it to be this mean of 3.5 that's in cell B13. So to make sure that B13 doesn't change to B14, 15, 16 as we copy it down, we are going to, on a PC, hit the button F4. And notice when I hit F4, it inserts these dollar signs. The dollar signs will fix that cell or fix that row or column so that they don't change. So $B means that it's always going to be column B. $13 means always stay in row 13. So B13, that cell will not change. If you have a Mac, you cannot use the F4 shortcut. You could just simply type in the dollar signs in front of the B and in front of the 13. There is a toggle switch or toggle button somewhere in one of the menus on the Mac, but I personally cannot remember where that toggle switch is. Once you have this typed out, equals, open parenthesis, click on the cell A5, minus, click on the cell B13 that contains the mean, hit F4 to get your dollar signs to make that a fixed cell. Then you're going to close your parenthesis, do Shift 6 to get the caret, which raises it to a power, and the 2. So we have 6.25. Now we want to copy that so I don't have to type this out every time. I'm going to copy that formula. To copy the formula, I am simply going to point to the bottom right corner of the cell where there's a little green square. When I point the cursor to it, it changes into a black plus, left click, drag down, and release, and everything's copied. That was the exact same thing I did over here when I copied the probabilities. Now this won't add up to anything in particular. It changes for every problem you're doing, but you see because we have symmetry, right, nice uniform symmetric distribution, we can see how we also have symmetry in the squared differences. Now the variance, recall, is the weighted average squared distance from the mean. It's weighted using the probabilities the same way we found the mean by weighting the X values with the probabilities. So we're going to do the same thing here, which means when we find the variance, which I'll abbreviate VAR, we're going to again use a sum product, but this time it's the sum product of the X minus mean squared column and the P of X column. So click in where you want the result. I can go to Formulas, Math and Trig, scroll down to Sum Product. Array 1 will now be my x minus mean squared column, so I highlight that, click into Array 2, that will be my P of x column, click on that. Since these two arrays are being multiplied and multiplication is commutative, it really doesn't matter which order you enter your arrays. So you could have put the P of x column in array 1 and the x minus mean squared column in array 2. That really doesn't matter. But now I click OK, and here I get 2.91667. But since we are working with values of the random variable that are whole numbers, we don't want this many decimals in our parameter. So what we call the mean and the variance, values that describe this probability distribution are called parameters. We don't need this many decimals because that implies too much precision. So we are going to round this down to only one decimal place. So we can go to Home, and over here in this number formatting area, I'm going to click the decrease decimal button until I just have 2.9. So there it is, 2.9. Now again, if you didn't want to go through the formulas menu, you could just as easily write equals sum product, start typing, double click on the sum product, and I'll just to show you they're the same, I'll highlight the P of x column first, comma, highlight the squared difference column next, close the parenthesis, enter 2.91667, but we'll go to Home, format the number by decreasing decimal to 2.9. So that's the variance, which is a measure of variation or spread. The issue might be, as you notice, is that we are squaring the differences, so everything has become bigger. It's been squared. It's now squared units if we actually had units here, and that wouldn't make any sense because here's the rule. What do we mean by a difference squared? So what we're going to do then is compute something called the standard deviation. And the standard deviation, which I will write as SD, is simply the square root of the variance, and that will undo the squaring. So to find our standard deviation, we want the square root. In Excel, the square root formula is SQRT. You could also find that in the Math Trig Formulas folder. We want the square root of the variance. All you have to do is click on the cell that contains the variance, close the parenthesis, hit enter, 1.70783. But just like the mean and variance, we only want this to one decimal place. So I'm going to decrease the decimals until it's 1.7. So here we've seen that for the experiment of rolling a fair six-sided die, where the sample space, or the set of all possible outcomes, consists of the values 1, 2, 3, 4, 5, and 6, where all the outcomes are equally likely because it's a fair die, then the possible values of the random variable consist of all elements in the sample space, so 1, 2, 3, 4, 5, 6. Since all outcomes are equally likely because we're told this is a fair die, then we know there's just 1 out of 6 ways to get each output. So each of these is 1 out of 6. Since this is everything in the sample space, the sum of the probabilities has to be 1. We can construct a probability histogram by highlighting the P of x column, going to Insert, Column Chart, and I did a 3D. I will choose a chart style, which I did 12. Then I go to Quick Layout, which will be 8, because that will close the gaps as well as give us axis labels. Fill in your axis labels, X for the horizontal axis, P of X for the vertical. Excel will scale this as appropriate depending on the size of the graph on your computer. We see that the shape is uniform, so I went ahead and labeled this as Uniform Probability Histogram. Since it's symmetric, the middle, which we call the average or the mean, which is a balance point, the expected value is right here at 3.5. It's actually a weighted average of the x values, the values of the random variable, weighted by their corresponding probabilities. So x times p of x for each of these values of x, add them all up, which means we compute a sum product of the x and p of x values. So that's what we did right here, where each array is highlighted in turn, and it doesn't matter which array 1 and which is array 2. Once we have found that, we can get a measure of spread or variation by finding the average weighted distance or average squared distance, which is weighted from the mean. So as I wrote it down here, we want the weighted average square distance from the mean. So we first have to compute the square distances. We did that with a formula, equals, open parenthesis, click on the first X cell, so that would be A5, minus, click on the cell with the mean, but to make sure that that cell is fixed and doesn't change as we copy it, we hit F4, which gives us these dollar signs, or you could simply type in the dollar signs, $B, $13, close your parenthesis, shift 6 to get the caret, 2 for squaring, then you will copy it by pointing to the bottom right, left click and drag, and then finally you're ready to compute the variance as a sum product of the x minus mean squared column and weighted with the p of x column. So x minus mean squared column, p of x column to get your variance. Since the variance was squared, we want to undo the squaring by finding the standard deviation, which is simply the square root of the variance. So to find the standard deviation, we take the square root of the variance and round that down to 1 decimal place as well. So we only want these to 1 decimal place because you only want to round your parameters. These are called parameters. Parameters are values that describe a characteristic of the probability distribution. We want to round these parameters to only 1 more decimal place than the values of the random variable. These are whole numbers, what we call discrete values, since they're whole numbers, so we only round the parameters to 1 decimal